MIT. Researchers have revealed a new thermophotovoltaic (TPV) cell that converts heat to electricity with over 40% efficiency, performance nearly on par with traditional steam turbine power plants. The cells have the potential to be used in grid-scale thermal batteries, generating energy dependably with no moving parts. Thermophotovoltaic cells work by heating semiconducting materials enough to significantly boost the energy of photons. At high enough energies, those photons can kick an electron across the material's bandgap, generating electricity. So far, TPV cells have achieved up to just 32% efficiency because they operate at lower temperatures. By contrast, the new design from MIT and the National Renewable Energy Laboratory, NREL, takes power from white-hot heat sources between 1900 to 2400 degrees Celsius, 3452 to 4352 degrees Fahrenheit. To do that, it uses high bandgap metal alloys sitting over a slightly lower bandgap alloy. The high bandgap layer captures the highest energy photons from a heat source and converts them to electricity, while lower energy photons pass through the first layer and add to the voltage. Any photons that run the two-layer gauntlet are reflected by a mirror back to the heat source to avoid wasting energy. This is an absolutely critical step on the path to proliferate renewable energy and get to a fully decarbonized grid. Measuring the efficiency using a heat flux sensor, the team found that power varied with temperature. Between 1900 to 2400 degrees Celsius, the new TPV design produced electricity with about 40% efficiency. Steam turbines can deliver the same efficiency, but are far more complicated and restricted to lower temperatures. One of the advantages of solid-state energy converters are that they can operate at higher temperatures with lower maintenance costs because they have no moving parts, MIT professor Asagun Henry told MIT News. They just sit there and reliably generate electricity. In a grid-scale thermal battery, the system would absorb excess energy from renewable sources like the sun and store it in heavily insulated banks of hot graphite. When needed, the TPV cells could then convert that heat to electricity and send it to the power grid. The experimental cell was just a square centimeter, so the team would have to ramp that up to around 10,000 square feet for grid-level power, but the technology already exists to create cells on that scale, Henry notes. Thermophotovoltaic cells were the last key step toward demonstrating that thermal batteries are a viable concept, he said. This is an absolutely critical step on the path to proliferate renewable energy and get to a fully decarbonized grid. All products recommended by Engadget are selected by our editorial team, independent of our parent company. Some of our stories include affiliate links. If you buy something through one of these links, we may earn an affiliate commission.